You already have your chapter and learning goal written down into your notebook because you took good notes, right, Jason? Today we are starting chapter 4, which is all about multiplying decimals. And chapter 4.1 specifically is talking about multiplication patterns with decimals. Okay, and our learning goal for today is to be able to find patterns in products when multiplying by powers of 10. There's a lot of very mathematical words in there. It says find patterns. We know what that means, right? We know what a pattern is. But it says to find patterns in products. What is a product? What is a product? Liam?
An answer to a multiplication.
The answer to a multiplication problem. So we're going to be looking at answers of multiplication problems, and we're going to be looking for patterns when multiplying by powers of 10. What does powers of 10 mean? We've talked about powers before. What's powers of 10, Shreya?
It's like the base number.
Yeah.
So 10, and then there's the smaller number on the edge, and then that's the power.
Yeah.
So if it's 10 to the power 3, that's 10 times 10 times
Yeah.
10 3 times.
Exactly. So when we're talking about powers of 10, we're talking about exponents, right? Exponents are that small number up here. And when it's powers of 10, that means the base number, Shreya, I love how you use that mathematical vocabulary word. The base number is always going to be 10. The base number is the number that gets repeated over and over and over again, depending on what the exponent is. Yes? Very good. Sarah? Says Cindy is combining equal-sized rectangles from fabric patterns to make a postage stamp quilt. Okay, she's basically making a quilt, sewing lots of different small pieces of cloth together to make a big blanket. Each rectangle has an area of 75 hundredths of a square inch. Okay, so they're like small squares. You can imagine this in your head. Squares that she's sewing together to make a quilt, right? Mm-hmm. Each rectangle's area, so the area of this is 75 hundredths square inches. Okay, that means that the length times the width of this each small square equals that. Okay? If she uses 1,000 rectangles to make the quilt, what will be the area of the quilt? Okay, let's talk about this. Are there words? Is this a math problem? Okay, what's the first thing we need to figure out then? What's the first thing we need to do, Joseph? And so what is the problem asking here?
If she used 1,000 rectangles
Uh-huh.
to make the quilt,
Yeah.
what will be the area of the quilt?
Yeah. The question is asking what will be the total area of the big quilt when she sews all 1,000 small squares together. Okay. Okay, step 2 then, Misaki, is to ask what is the important information here? Yeah, each rectangle has the area that is 75 hundredths, or 0.75 square inches. Is there any other important information we need to know? Equal sign? Look, let's look at it. So we know that each rectangle is 75 hundredths of a square inch, and we're trying to find out how big the total area is going to be. What's the missing piece? What do we need to know also? Yeah, that there's 1,000 rectangles all together. So what math operation would we use? Addition, subtraction, multiplication, or division? Rashika? Why would you use multiplication? Yeah, we would do 1,000 times 75 hundredths to find the total area. Now, is multiplication technically the only operation we could use? Claire? Why could we also use addition? I agree that I prefer to use multiplication in this case, but why could we also technically do addition? Arushi?
Because multiplication is just repeated addition.
Right, multiplication is the same thing as repeated addition. So could I also do 0.75 plus 0.75 plus 0.75 plus 0.75, etc.? How many times would I need to add it? Tanvi? 1,000. But of course, multiplication is a little bit easier, right? So what we can do is we can use a pattern. Is 1,000 a power of 10? Can I do 10 to the power of something? To the power of what? 3. 10 to the third power is 1,000, right? When we're dealing with powers of 10 and multiplication, we can look for patterns. Okay, so this is what I would like you to write down in your notebook. I want you to write down this pattern. You will see first when we do what 1 times, whoa, lightsaber, cool. 1 times 75 hundredths is what? What's 1 times 75 hundredths? 75 hundredths. What's 10 times 75 hundredths? What is it? What do you guys see? What is it? What is it? 7 and 5 tenths, 7.5, right? What about 100 times 75 hundredths?
75.
Huh, okay. And 1,000 times 75 hundredths is? 750. Go ahead and write down that pattern. And then take a look at the pattern. What patterns do you see after you write it down? If there are 1,000 rectangles and each rectangle's area is 75 hundredths, how much area will the whole quilt have? How much area will the whole quilt have? Sidar?
The whole quilt will have 750 square inches.
Yeah, because 1,000 times 75 hundredths is 750. Now let's talk about this pattern that we've been discussing. As you multiply by increasing powers of 10, how does the position of the decimal point change in the product? How does it, every time I increase by a power of 10, what happens to the decimal point? Rashika?
So I think this is so every time the exponent goes up one,
As I increase by a power of 10.
the decimal moves the same number of times as the exponent shows.
Decimal moves.
So like if we say it's 10 to the third power,
Mhm.
we see the decimal moves 3 times
To which? To the left or to the right?
to the right.
The decimal moves to the right. The number of the exponent, right? We can use what we know about place value patterns to find the product of a number and the decimals 0.1 or 1/10 and 1/100th also. Okay, so any number times 1/10 we can solve it, and any number times 1/100th we can also solve it, right? Just like we can do any number multiplied by 10, 100, 1,000, 1,000,000, anything, right? Okay, so let's look at this. George is making a scale model. Okay, he's going to build a little tiny scale of the Willis Tower in Chicago for a theater set, for a play. The height of the real tower is 1,353 feet. If the model is 1/100th of the actual size of the building, how tall is the model? Okay, so of course the question is asking how tall is George's model? The important information we need to solve the problem is that the real tower is 1,353 feet and the model is 1/100th of the actual height. So we would solve this problem by doing 1/100th times 1,353, right? Okay. When it's 1/100th of, this word of, anytime you see the word of in a multiplication problem or in a word problem, that means you need to do multiplication. I want you to write this down right now. Anytime you see the word of, like 1/10 of some number or 1/100th of something, that means you need to do what mathematical operation? Multiplication. Write this down. So then, if we're trying to find out what 1/100th of 1,353 is, we would do what mathematical operation? Multiplication. Okay, very good. So, 1/100th. Can we write that as a decimal? What's 1/100th as a decimal? Liam?
So in word form it would be 0 and 100, but how would you would write it as 0.01.
Yeah, so 1/100th times 1,353 is the same thing as 0.01 times 1,353, right? Is our product going to get bigger or smaller when I multiply by a fraction? Smaller. So to make it smaller, do I need to move my decimal point to the right or to the left? To the left, yeah. How many spots am I going to need to move it to the left? 2, because I'm dealing with 1/100th, right? And as you can see in this pattern, I want you to write down this pattern as well, just like you wrote the other pattern. 1 times 1,353 is? 1,353. 1/10 times 1,353, the decimal point moves 1 spot over to the right. So it's, or sorry, to the left. It equals 135 and 3/10. Now what about 1/100th of 1,353? How many spots over to the left am I moving the decimal point? Adam?
2 spots.
2 spots, and when I move it over 2 spots, what is the answer? Karan? 13 and 53/100. So therefore, George's model of the Willis Tower is how tall, Jason? (13 and 53/100 feet tall.